Hello again, Dr. Escobar.
Good morning. Well, it's 9 o'clock straight up, shall we?
Let's go ahead and get started.
All right. So, good morning, boys and girls. It is so good to be with you once again for our third and final virtual field trip.
Dr. Escobar.
Good morning. Well, it's 9 o'clock straight up, shall we?
Go ahead and get started.
I think you could hear that, right?
Yep, I could.
Our third and final.
Oh my goodness.
What did you tell me to do?
On YouTube, if you have the stream playing, just mute the YouTube stream.
Well, it's 9 o'clock straight up, shall we? All right, I tell you, this technology. But again, boys and girls, it is so good to be with you as we come to the close of our summer school session. Will be done on Wednesday. It is our hope that you were able to learn a lot this summer. And as you probably know and heard in the news, we are going to continue with our distance learning. And so as we get better with technology, we will be doing a lot more learning as time goes on. But I want to welcome our very special guest, Mr. Lyle Tavernier. He works for JPL NASA, and it is our privilege to be with him once again as he's going to share with us some more of the magic that they do at JPL NASA. So with that said, Mr. Tavernier, it's all yours.
Thank you very much, Dr. Escobar. Good morning, everyone. It's nice to be with you all again. Hopefully you have all been here for the last two sessions. And so you remember we talked about what an engineer is. So think about that for a moment. And remember, an engineer is someone who builds things or improves things to solve problems. And last time we talked about one of the problems that we have at NASA is that we want to explore planets, but they are millions of miles away. And so we have to engineer or build ideas that will help us explore those places. And one of the things that we do is we build robots to explore Mars. And we talked about the Perseverance rover. And I'm going to show you a picture of the Perseverance rover, just to sort of refresh your memory. There you go. So here's the Perseverance rover as we were building it in, this was, I think, back in December. And all those engineers you see in the back worked a lot of hours to build that rover. In fact, it took many, many years to build the rover. Now we actually have to get it to Mars, which is another challenge. And one of the things that we do in order to make that happen, oh, here's the other picture of the rover. So this is here at JPL in Pasadena, but we don't launch it from Pasadena. You can't launch rockets where there are lots of people around. We want to make sure that everyone is safe, and so we launch rockets far away from people. And there's a place in Florida that we launch the rockets from. It's called the Kennedy Space Center. But we can't just drive the rover over there. We have to really, really do some special packaging to make sure that it gets there safely. So what you're going to see here is a video of when we packed the last rover up. And let me just jump forward a little bit. I thought I had trimmed this part out. Sorry about that. Here we go. This is sped up. So here's the rover getting packed up. It takes about 2 days to get it ready to go to Florida. There's a lot of work that has to be done to make sure that it's safe to bring a rover to Florida so that the rover doesn't get damaged. You can see it takes a lot of engineers to make sure that everything is packaged up the way that it's supposed to be. Once it gets wrapped up, we actually put it in a box, very big box, and put the lid on it, and it is ready to go. But we also have to then take that very big box and put it into an airplane. So inside that box that you see is the rover. And you can see how big it is by seeing this person over here in the bottom right corner to give you an idea of how big that box is. And we put it in the back of an airplane and we fly it from California all the way to Florida. Once it gets to Florida, you can see the engineers here are unwrapping it to make sure that it arrives safely. So that silver blanket that you saw we put around it to protect it, that has to come off once it's in Florida. And once it has its protective wrapping taken off, you can see it looks a little bit like this. We keep wrapping on the wheels because the wheels have to be extra, extra clean. But this is what it looks like. So we do a lot of work to make sure that it gets to Florida safely. But it's not the only piece. I've been talking about the rover, the robot that will drive around on Mars, but there are a lot of pieces that help it get to Mars and land safely on Mars. So here's another piece that gets sent to Florida. It's built here in Pasadena. And you can see, just like the rover, it was wrapped up in that silver wrapping, and it was also put inside of a box so that it could be safely transported. Just like when you send something in the mail to somebody that you don't want it to break, you have to package it up safely and carefully. That's the same sort of thing that we do with the rover. So there are quite a few different pieces that help the rover get to Mars safely. So you can see them all here sort of spread out. There's one piece at the top, two, three, four, five total pieces that help this rover get to Mars. And we have to put them all together. So engineers not only had to build the rover, but they had to build all of these pieces. So landing on Mars is another problem. It's very difficult, and engineers had to build things that would help the rover land safely on Mars. So we package it all together. I'm going to show step by step the way that everything sort of closes together to make a nice little space capsule. This is what we actually send to Mars. And so once all the pieces are in Florida and we put them together, it looks like this. And you can see here the engineers underneath checking it to make sure everything is connected the way that it's supposed to be. Once all those pieces are put together and the engineers check it out, we have to put it inside the rocket. And the first thing we do, if you've ever seen a picture of a rocket, you'll know that at the very top, there's what's called the nose cone. That's sort of the pointy part at the top of the rover, or at the top of the rocket. And that pointy part is where the rover will go in. And you can see it's a really, really big, big space to be able to hold what looks kind of like a small spacecraft. But we know the spacecraft is pretty big because we've seen the pictures of the people standing next to it. So knowing that this spacecraft is very large, this rocket is even bigger. And this is just part of the rocket. So we take both of those halves and we close it together. And then we're going to take what you see on the screen and we're actually going to put it on top of the rocket. It's a very, very large rocket. So we have to drive from where we unpacked the rover. We have to drive that nose cone from the rocket all the way to the rest of the rocket. So the rocket itself is pretty big. Here you can see part of it. This is before we stand it straight up. We lay it down because it's a little easier to move it when it's laying down. And then we take that piece, and here you can see it circled in red. That's the part that goes to Mars. Everything else that you see that's part of this rocket is used to give it a nice push to Mars. We've got to get it going really, really fast. So we use a very big rocket. But the only thing that actually goes to Mars is this part up here. And so what I want to do is I want to take some time to answer your questions. So if you've had any questions about what we've been talking about so far, whether it's the rover or packaging it safely or sending it to Mars, or even sending it to Florida and then getting it ready in Florida to go to Mars, you can send in your questions to Dr. Escobar. And if we don't get to your question this time, we'll stop a couple more times for questions too. So Dr. Escobar, do we have any questions that have come in about the rocket or about the rover?
Well, I think these questions came in prior to your presentation, so we'll start with those. The first one is, are there education programs for students that they can sign up individually at JPL or NASA?
So we don't have like a volunteer program. Now, when students get to college, we do have programs, we call them an internship. And an intern is somebody who is learning how to do something in school and then comes to JPL to practice doing those things. So if you want to be an engineer, you might go to college to become an engineer. And while you're in college, we give you or we give students the chance to come to JPL and practice being an engineer. So in fact, on the Mars 2020 rover, the Perseverance rover, there are quite a few interns who are in college but came to JPL to practice their skills and learn how to become engineers. And they got to do it on an actual spacecraft. So we do invite students to become interns when they're in college. But we don't have a summer camp like you might think of that you do for your school. Oh, Dr. Escobar, I think you're muted.
Thank you. And the next question is, where do you think we will be able to go to after Mars?
Oh boy, that's a great question. So we have a few different ways that we can think about that. Um, if we're talking about any kind of spacecraft, so we're sending this to Mars in just a couple of weeks. In fact, we launch on July 30th, so at the end of this month. Um, we have missions planned to go to the moon. We have a mission that is being designed by engineers and built to go to, where is it going? Saturn. But it's not going to the planet Saturn. It's going to a moon that goes around Saturn, and it's going to land on the moon. So we're pretty excited about these types of missions too. We have a mission that we're building at JPL that will go to one of the moons of Jupiter. So we have been to these giant planets before, and we want to explore some of their moons as well. So there are lots of different ways that we can answer the question of where are we going next. With humans, we're kind of limited though. Probably the moon and Mars right now. Maybe in the future someday we could go to the moon of another planet, which would be pretty cool too.
Thank you so much. And then the next question goes as follows. My mom has seen on the news that people will be able to travel to space. Is this true?
So there are a few companies right now who are making rockets and spaceships that will allow not just astronauts from NASA or other countries to go into space, but people who um, are just interested in traveling to space. If they have money, and it's a lot of money, if they have a lot of money, they could buy a trip to space. So I think I can think of about two or three companies off the top of my head that are planning on sending, they call them space tourists. So instead of going to another state or another country as a tourist, you could be a tourist that goes into space. So as far as I know, there aren't any of the companies doing it yet, but I would imagine in a few more years they'll be pretty far along in those programs. And if you have a lot of money, you could probably buy a trip to space.
Very good. Thank you. All right. Those are the questions we have thus far.
Okay, let's go ahead and talk a little bit more about sending this robot to Mars. And again, if you've got questions, you can email them into Dr. Escobar, and we'll take those in just another couple of minutes. So on the screen, you still see the rocket that will push the rover and the rest of the spaceship to Mars. And this is a drawing of what it looks like. We haven't launched yet, but I do have a video of another rover that we launched, the Curiosity rover. We launched it in 2012, or maybe it was 2011 now. It's been quite a while. I think it was 2011. Yeah. And I have a video of what that looked like. And it's a very similar process for the Perseverance rover because the rockets are the same and the rover is about the same size, and we do the same sort of thing. We put it all together in that small package that sits at the top of the rocket. So this can give you kind of an idea of what the launch will look like in just about 10 days. So if you want to practice your counting skills, we're going to count backwards from 10. I don't know if you'll be able to hear it actually. Let me turn my volume up so you can hear it. But you can see here the rocket on the launch pad. I'm going to hit play.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
So I'm going to turn the video down just a little bit, but you can see that very large rocket. It's hundreds of feet tall with the rover on top. And it's going to launch for quite a while. It takes about 8 minutes to get up into space. Before it gets all the way up there, part of those rockets, you see the smaller, shorter ones near the bottom of the rocket, those will actually run out of fuel. And we don't want to carry around the empty part, so we're going to just disconnect them. And you'll see it in the video. They'll come off in just a few moments. There they go. And then in a few moments, you'll see the nose cone of the rocket. Remember those two parts that close? You'll see it pop open. There they go. Now the rover is ready to be pushed off to Mars. And I think I've got a video that will show what it looks like when it gets pushed off all the way. There it goes. That is the top of the spacecraft on its way to Mars, and it's getting ready for its long, long trip to Mars. So that's what that part looks like. The next part is we have to get to Mars, and it's a long trip to Mars. In fact, it takes about 8 months to get there. So when we launch the Perseverance rover in 10 days, it will have to travel the month of August, September, October, November, December, January, so 6 full months, plus another 18 days in February. So it's going to be taking quite a long trip. Depending on the when we launch and how fast the rocket's going, it can take anywhere from about 7 to 9 months. So it's quite a long trip. And I have a video. Whoops, we already watched that one. Of what it looks like traveling to Mars. So here it is at the top of the rocket. It's getting its final push. This is the view we just saw of the spaceship getting its push to Mars, and it's going to travel to Mars over millions of miles. And when it gets to Mars, it's going fast. It's going really, really fast, faster than any car can go. And we have to slow it down to carefully land it on the surface. So we have a very big parachute that pops out of the back. Engineers had to design the parachute, but the parachute will only slow us down so much. So we drop off the parachute and we use a special rocket-powered crane, we call it the sky crane, to gently lower the rover down onto the surface. Once it has safely landed, the sky crane disconnects and flies off into the distance. Keep in mind, an engineer, not just one engineer, but many engineers, had to design and build all of those different pieces that we saw to help the rover safely get to Mars. Now this is the video of the Curiosity rover. So I'm going to skip forward because, whoop, keeps restarting my video. I'm going to skip forward because this is a video that we made for the Perseverance rover. And you'll notice they look very similar. There are little differences. If you look closely, you might notice a little difference here and there. The mast or the head is a little bit different on this one. The wheels are a little bit different. The robotic arm is a little bit different, but it has all of the same main parts. And so this kind of gives you an idea of one of the things that the rover might do once it's on Mars. It will have this robotic arm that can reach out, just like you and I have a robotic arm. And just like you and I could pick something up off the ground, this is actually going to use its tools to drill and collect rock samples that we'll be able to collect in the future. So this is sort of like if we had X-ray vision and could view into the rock and see it being cut out. We take that little piece of rock about the size of my pinky, and we're going to put it for safekeeping inside the rover. And here we'll do another one of those X-ray vision views where we can see inside the rover. And that yellow tube, that's where the rock sample is. And it's going to be safe in the rover until we're ready to put it down on the ground. And maybe someday in the future, we will be able to collect it. So we're pretty excited about this rover and what we'll be able to do with it. But remember, this is a robot. It's a machine that does jobs for us that we tell it to do. And it was built and designed by engineers, people who build things and improve things to solve problems. So we're pretty excited about this, and I hope you are excited about it, and I hope that you have an opportunity to watch it on July 30th. You'll have to get up really early in the morning. I think our first chance to launch this rover is going to be at about 4:30 in the morning on July 30th. So you have to tell your family really, really nicely. You'll say, can we please get up really early and watch this? And if you start asking them very nicely now, after 10 days, hopefully they'll be convinced that they should get up very early in the morning with you and watch it. It will be on NASA TV and YouTube. So if you just look for the Perseverance rover launch, you'll be able to find it. It will be a lot of places. So Dr. Escobar, that's sort of a good summary of the mission to Mars. So I wanted to see if any students had any other questions.
All right. These are the next questions. How do you talk to the spacecraft to be able to get it all the way to Mars?
Oh, that is a good question. And I'm wondering, I might have some, I'm going to stop sharing because I might have a picture of it. That's a really good question. How do you talk to a spaceship that is millions of miles away? And we have something called the Deep Space Network. And let me see if I can find a picture from the Deep Space Network. The Deep Space Network is a group of 3 different communications or satellite stations around the world. And so let's see if I can share this video, or not video, excuse me, this picture. Thanks for your patience while I get this going here. Let's see. Here we go. All right, so you should see right now a very, very large satellite dish. And it's hard to see how big it is because there's no people around, but this is almost as big as a football field. It's huge. It's 70 meters across, which is, gosh, that's over 200 feet across from side to side. So it's a very, very big communication tower. This is here in California. And we also have one in Australia, and we also have one in Spain. And so these very large antennas can communicate with the spacecraft. We send signals back and forth from the spaceship to Earth, and from Earth to the spaceship. Great question.
Excellent. Thank you for that. Okay, the next question is, does it use gas to drive the engine on the rover?
It does not use gas. What an interesting question. So I'm going to have to find a picture of the rover that will show us where we might be able to see it. I think I have a picture that will show that though. It doesn't use gas for a couple reasons. There's no gas stations on Mars. So if we run out of fuel, we wouldn't be able to add any gas on Mars. There's no gas stations, and there's also no one to fill up the rover with gas. It has a robotic arm, but it's not able to fill up. Let's see, do I have a picture? I thought I did. This might do it. Okay, let me share this picture with you. It'll take me just a second here. And here we go. All right, this is a very technical drawing with all the different pieces of the rover in different colors to make it easy to see. But in the back, on the left-hand side of this picture, near the back, there is something that has a very fancy name. Are you ready for this? It is called a radioisotope thermoelectric generator, which is a lot to say, but we make it a little shorter. We call it R for radioisotope, T for thermoelectric, G for generator. So RTG. And the RTG is what gives us power. So there's some plutonium in there. Think about that word plutonium. Maybe you've heard of plutonium before. Plutonium is a special kind of material, and it gives off a lot of heat. It's called radioactive. And when it gives off a lot of heat, we can collect that heat. That's what the rover does. It collects the heat from the plutonium and it turns it into electricity. And the electricity charges batteries, And that's what the rover uses. So it doesn't use gasoline, it actually uses electricity. So it's kind of like an electric car, but just a little bit different.
Very good. Thank you for that. And the last question we have so far is, will they be using the plane spaceship again? And I think they're referring to the space shuttle.
I think so, yeah. So good questions, and hopefully we'll have a couple more. So if you have more questions, feel free to send them in to Dr. Escobar. But the plane ship, I wonder if, gosh, I thought I was just looking at a picture of one of those. Um, but maybe I don't have a picture of it. So the space shuttle is what we used for quite a long time. From 1981 until 2012, we were using the space shuttle. It launched over 135 times. And we didn't plan on using it for that long, but we needed to use it for that long. So we retired it. It won't be used again. But what we're doing now is we are sending humans to the International Space Station using companies like Boeing and SpaceX. So Boeing and SpaceX help NASA out by letting us use their rockets and their space capsules to send humans into space. So right now there are 2 astronauts on the International Space Station who flew to the space station on a SpaceX rocket. And later this year or early next year, Boeing is planning to launch some astronauts to the International Space Station also. So we won't be using the space shuttle anymore. That's the one that had the wing design. But we will be continuing to send astronauts into space. Very good question.
Thank you. Thank you so much.
Pleasure.
All right. That was the last of the questions. So we're waiting for some more to roll in.
Okay. Well, while we're waiting, Dr. Escobar, do you have
Yes.
any questions?
Do I have any questions? Absolutely. You know, the idea of oh my goodness,
Colonizing.
colonizing, my goodness, another moon or a planet. You hear about these things in the news. What are your thoughts about the feasibility, the possibility of that?
So when we talk about going to another planet or another moon and staying there for a long period of time, not just a couple days or a couple months, but maybe setting up a long-term habitat that would allow humans to survive for a long time, I think that's a really interesting idea. I would love to be able to think of humans as a species that has um, habitats in different places around the solar system. I think that would be really, really neat. I also know that there are a lot of challenges that we have to overcome, a lot of problems that we don't have the answers to. And so what that means is we need a lot of engineers to help solve those problems. So I think it would be really neat to have a habitat near the North Pole or the South Pole of the moon, because habitats in those places would allow us to get daylight and some darkness. Um, the moon is a pretty interesting place. If you're on the sunny side, it would be sunny for about 2 weeks, and then you'd have about 2 weeks of darkness. So you'd have to kind of get ready and be prepared for that sort of weather. But we do that in Antarctica now. We have people who live on Antarctica who are in the dark for months at a time. So it's something that we practice and are finding ways to prepare for. So I think it would be pretty neat to have some habitats on Mars and on the moon, but I think it'll be a little while before we get there.
Very good. Well, now let me turn the tables on you. What is your biggest question? What is it that your thoughts are, your envision? What keeps you up at night?
Boy, that's a good question. I think my 2 biggest questions are what will happen to the universe in the future. So I don't mean tomorrow or next month, but in billions of years or even trillions of years. Right now, the universe is getting bigger and bigger and bigger. And I wonder, is it going to keep getting bigger? I wonder, does the universe have like an end. And then I sort of wonder, is there life out there? Which I think is a question a lot of people have. And the Perseverance rover is going to be looking for little signs of microscopic life that might have been on Mars once. But I'm also curious about maybe more evolved life like we have here on Earth, more than just small bacteria, but maybe large space animals of some kind. I think that's a pretty neat thing to think about. And you can use your imagination and think about what they might look like, where they might live. And that's actually something that scientists do. They think about what life on another place might be. They can use their imagination to think about those things. And if they think about the place and they know what the place is like, whether it's hot or cold, liquid or solid or gas, they can think about what it would take to survive. And so, kind of using your imagination and thinking like that is sort of a neat way to imagine what the universe might be like in places that we can't go to or haven't been to yet.
Got it. Thank you. Thank you for that. When you did this, I thought you were going to say that it's looking for little green aliens. I thought that's what you're going. It's just you're right. The universe is ever expanding. You know, the number of stars and planets is just mind-boggling. The billions of stars and the trillions of, planets. It's hard to believe that we're all alone.
Yeah, yeah.
Yeah. So, I'm looking at the clock. I know we've come to the end of our time. And at this point, unless you have any closing remarks, we want to take a moment to thank you. So thank you for the 3 field trips. You took us places we never envisioned we'd go to this summer. And so on behalf of the students, the teachers of the Los Angeles Unified School District, we're so appreciative of your time and of your service to us. Thank you.
Thank you. Thank you very much for the opportunity to talk. And I hope that everyone learned something. I hope that some of you might be inspired to become engineers someday. And if you work for NASA, come say hi to me. And even if you don't work for NASA someday, I hope that you have maybe just learned a little bit and will appreciate space travel in the future. So from all of us at NASA, have a great rest of your week, and hopefully we'll see you in the future.
Thank you. Thank you so much. Thank you, boys and girls.